families. Mothers who lost their children's support will unable to sustain themselves in retirement and will forced to live in the street. This study is necessary for the creation of the program in Sub-Saharan Africa for bereaved mothers whose child died at any age. This study indicates the geographical location of mothers who suffer in child death and predictors of child death and mothers who suffer in child death. It is all about my introduction part. Next, I will discuss in the method parts. For this analysis, I used two different data sources, which are demographic and health survey and multiple indicator cluster surveys. In this study, I include about 400,000 of women and 1.5 million of children from those women. Those women and children comes from about 17,000 of clusters. These clusters in 417 regions or provinces or admin ones. In general, in this analysis, used 14 Sub-Saharan Africa countries or admin ones. For this analysis, I used two dependent variables. The first one is women who lost at least one child or not, and the second is the number of child who have died in each woman, which is count. The number of child in each woman is 0, 1, 2, 3, 4, which is count. And the first one is women who lost at least one child is binary, which is either at least one child lost or not. In this analysis, women at fertile age or whose age is 50 to 49 included, but from those women who have not given at least one child is excluded from this analysis. Before any intervention or any analysis, the data for the 42 countries data merged into a single data set. Then start to analyze. For this analysis, I used two different models. The first one, geospatial model and factor analysis models. In the geospatial models, three sub-models. The first one is hotspot analysis. In the hotspot analysis, used to identify statistical significance, spatial clustering of high value or hotspot and low value or cold spots. For this analysis, I used GeoDGIS. For this analysis, used polygon-based, polygon in region or province-based prevalence. This analysis is compared to each regions compared to their surrounding regions. And the prevalence is high, it is hotspot, and the prevalence is low, it is cold spot. The second is spatial scan statistics analysis. This analysis higher aggregate concentration of instances were included in the circular windows. For this analysis, use StatScan and QGIS, combined of StatScan and QGIS. For this analysis, it shows the concentration, the number of cases based on the number of cases and the number of population. When the number of cases is higher concentration, it shows in the circular windows. In the circular windows, compared to their surrounding, the case is higher. The third or the last is the spatial interpolation. The spatial interpolation is to predict and measure area based on their neighbors, two or more neighbors of measured area, which is used to SAGA-GIS. The next is multi-level for factor analysis. In the previous, I can show where is the place in high risk or the most hotspot area. In the next, for those areas, which group of pupils are more high risk, which group of mothers, which group of mothers who comes from households, who comes from communities. Due to hierarchical nature of DHS or MIS data use can be used different levels because individual is nested within household, household nested within community, community nested within the region or province, province nested within countries. So for this such type of data, use two or more level analysis, but I used only two level analysis. The lower level is maternal characteristics and the higher level is community or enumeration area characteristics. For this analysis, I used two different sub-models. The first one is the binary logistic regression, maternal suffering of child death. For this analysis, which is the outcome variable is two binary outcomes, which is the mothers who lost and at least one child death or not. For such type of analysis, used logistic regression, in multi-level logistic regression. The second is negative binomial regression for number of child deaths. The number of child deaths each woman is the minimum of 0, the maximum 13 in Sub-Saharan Africa, included in this analysis. So in each woman, 0, 1, 2, 3, 4, 5, and so on. So it is called count. In the count, used to Poisson regression. Poisson regression, when in the Poisson regression, the variance is greater than the mean, which is over dispersion. During over dispersion of Poisson regression treated by negative binomial. So my data is over dispersion. I use negative binomial, multi-level negative binomial regression. For all findings, spatial or factor analysis, weighted method is implemented because both MICS and DHS data have its in each individual have its own weight values. It is all about method sections. Next, I will discuss the result parts. In Sub-Saharan Africa, a woman included in this analysis, a woman in average has 3.8 children. Out of all children, about 1.5 million children of 180,000 of them died, which accounts 12% of children in Sub-Saharan Africa were died. And mothers who suffer in childbirth, out of 400, about 400 mothers, 110 out about 110 mothers were suffers in childbirth, whose account is 27% of mothers included in this analysis who live in Sub-Saharan Africa suffers at least one childbirth. From mothers who have experienced childbirth or at least who lost at least one childbirth, in average 1.7 child in average lost. And this error bar graph indicates in each country the mothers who suffer in childbirth, the percent of mothers suffers in childbirth. In Sub-Saharan Africa, in average 27% of mothers who suffer in childbirth. And the highest contribution of childbirth found is in Nigeria, Chad, Burkina Faso. Mothers from those countries comes from those countries where out of 5 mothers, above 2 or more mothers were suffers in childbirth. And the lowest proportion of or prevalence of mothers who suffer in childbirth found is in South Africa, Sao Tome and Prince, Somalia. From the mothers from those areas, out of 10 mothers, only one of them were suffers in childbirth. Spatial epistemology by residence. This error bar graph indicates by mothers who suffer childbirth by residence. The green color indicates the urban, the rural area, and the red color indicates the urban area. In the rural area, the highest contribution of Niger mothers. In Niger, half of Niger mothers who live in rural area were suffers at least one childbirth. And the next were Chad and Burkina Faso. Mothers from Chad and Burkina Faso, out of 5 mothers, 2 or more mothers were suffers in childbirth. In urban area, mothers from Liberia, Chad, and South Africa, out of 10 mothers, 3 of them were suffers in childbirth. And the lowest proportion of mothers who suffer in childbirth in both in urban and rural areas found is in Somalia, Sao Tome and Prince, South Africa, which accounts about 10% of them were suffers in childbirth. Children died in Niger at a rate of 20%, or out of 5 children in Niger, 1 of were died. And Burkina Faso and from Burkina Faso and Liberia, 70% of them were died. Next, I will discuss about among the older age, among mothers whose age 45 to 49 at the end of childbearing mothers, where in these mothers, on average, in Sub-Saharan Africa, each woman have 6 children in average. Mothers in Niger and Chad have the higher number of children, which accounts 18 in average. And the lowest is in South Africa, which is 3 children each woman. And this error bar graph indicates the older age, or 45 to 49 mothers who suffer in childbirth. In Sub-Saharan Africa, about half of them, or 48% of Sub-Saharan Africa women whose age is 45 to 49 were suffers in childbirth. The maximum percent of mothers who suffer in childbirth found in Niger. Mothers from Niger, out of 5 mothers, 4 of them were suffers at least one childbirth. The next is found in Mali, Ethiopia, Uganda, Burundi, Rwanda, Chad, Liberia, Burkina Faso. Mothers from those countries, out of 5 mothers, 3 or more of them were suffers in childbirth. The lowest proportion or prevalence or percent of mothers who suffer in child death is in Somalia, South Africa, Namibia, Zambia, and so on. Mothers from those countries below, out of 4 of them, below 1 of them were suffers in child death. And this graph indicates that the GDP per capita in each country and the prevalence of child death, which indicates the red color indicates the child death, the green color indicates mothers who suffer in child death whose age is 45 to 49, and the blue color indicates mothers who suffer in child death in all age groups or whose age is 50 to 49. All are in, when the capital, the GDP per capita increases, the prevalence or the percent of mothers who suffer in child death and the number of child deaths were decreased. This map indicators, these 4 map indicators different situations. The first and the second based on polygons. This polygons is a region or admin one or provinces. In the first shows in the prevalence. The prevalence is indicates, the red color indicates the mothers who live in this red color regions, 36% or more of them were suffers at least 1 child death. And the orange color indicates 26 to 35% of mothers who live in this orange color were suffers at least 1 child death. And the lowest is the green color indicates below 60% of mothers who live in this green color regions where suffers at least 1 child death. And the next indicators used to hotspot and cold spot or high value or low value of the child mothers who suffer in child death. The red color indicates the red color indicates the hotspot or the high value compared to their surrounding regions, not their own surface. So compared to their who's found this in Western Sub-Sahara, most of them, Western Sub-Saharan Africa, some of them, Eastern Sub-Saharan Africa, most of them, but in Western Sub-Saharan Africa. The next 2 maps indicators based on cluster prevalence and based on the cluster. This is the cluster count method. The next is interpolation, the cluster prevalence. The first is indicates that it is circular windows compared to their surrounded, the number of cases and populations compared to the number of cases they are surrounded, the higher concentration of the cases is in the circular windows. For example, the first circular windows found at here. This indicates that the expected number of cases in this circular windows were about 3,000, but 6,000 mothers who suffer in child death found in this. The relative risk is 1.7, and 46% of mothers who lives in this circular window suffers in child death, and so on. The last one is interpolation. The interpolation is due to predict measure and measured area based on measured area, which is cluster prevalence based on cluster prevalence. Thus, the red color indicates the highest contribution of mothers who live in these red colors, where the highest contribution of mothers who suffer in child death, about above 45 or 15% of them were lives in these red colors where suffers in child death. And the lowest is approaches to below 10% of them, the mothers who live in this blue color which suffers in child death. The last is indicators that the factor analysis. The factor analysis is to adjusted odds ratio and adjusted incidence ratio. Adjusted odds ratio were used who mothers who suffer in child death or not, which is binary outcome, which used to multi-level logistic regression. And the adjusted incidence rate ratio, the in each human, the number of child in each human, which is count its Poisson, it is negative binomial, multi-level negative binomial regression. In this vertical line indicated below the vertical line, the reference is more protective and the reference is more risk, the other is protective. And above the red colors is indicates that the reference is more protective, the other is more risk. For indicates that for the first is education, no education is reference. So the primary education, secondary education, and higher is protective compared to no education, and so on. For this pie chart indicates that The mothers who suffers in childbirth is based on the number of children. The green color indicates the mothers who not lost any children is this 73% of them were no children, and the blue color indicates 70% of mothers lost only one child, and the yellow color indicates the 6% of Sub-Saharan Africa mothers suffers two child deaths into lost two child in each woman, and 4% of mothers three or more, 3, 4, 5, 6, and so on. Lost in general, 10% of mothers two or more child lost. It is all about the result matrix. Next in the conclusion parts. Almost all area of Western Sub-Saharan Africa and some of Eastern and Central Sub-Saharan Africa, like Ethiopia, Democratic Republic of Congo, Mozambique, and others, are contribute the high case of mothers who suffer child death and the number of child deaths. Mothers have not HIV neurology, stunted, wasted, older, uneducated, household head is not her husband or partners, unimproved toilet facility and water sources, low age of first birth, more than one number of unions from rural residents, more temperate ecology, contribute a higher number of child deaths or suffers in child death. Thank you for demography and health survey and cluster indicator survey. And again, I would say thank to the program, the organization of this program. And anyone who have a question, you can ask.